Alright, this is examples 8-1, and here they got some extra information here. So n is equal to 25,000. So our sample size is 300. So we talked about this before about the 5% rule. So let's look at that. 300 divided by 25,000, and I want to get what that number is here. So 300 divided by 25,000, and that equals to 0.012. So that's less than 0.05. So that's less than 5%. So the sample size is less than 5%. That's good. And then the author also wants you to check n times p times 1 minus p. And so in that case, this is 300, and that has to be greater than or equal to 10. So 0.7, and then 0.3. So I'm going to go find out what that is. So 300 times 0.7 times 0.3, and that gives me a number of 63, and 63 is greater than 10. So the sample, or the distribution of the sample is assumed normal. Now we saw that in that video, or in the video where the blocks were falling. We sampled 300, size of 300. We only could sample 20, but when we sample 300, we get a really narrow thing. So now they want to assume that the sample size is 25, and so now they want us to find the parameters here. So mu of p hat is equal to p. You can find these on your formula sheet in Chapter 8 stuff, which in this case is 0.7. And then sigma of p hat is the square root of p times p, or 1 minus p. Where is it here? Okay, 1 minus p. So 1 minus p all over n. So in this case, that's going to be the square root of 0.7 times 0.3 divided by 300. And then I'm going to put that in the calculator here. So second square root of 300, or no, 0.7 times 0.3 divided by 300. And that equals to 0.026 and some change. So that's the standard error of the proportion p. Okay, so for a sample size of 300. All right, next problem here. All right, suppose that a random sample of 100 people is asked, are you satisfied with the way things are going in your life? Is the response to this question qualitative or quantitative? Well, the response is satisfied or not satisfied. Which is a qualitative response. So they can only have an answer of satisfied or not satisfied. All right, so the next one here, explain why the proportion p is a random sample. Okay, so we have n equals to 100, and we asked the people, are you satisfied? And so p hat is satisfied, is satisfied. So our success, or probability of our success thing, is p hat is satisfied. So that makes it a random variable. What is the source of variability? Well, you can have two things. So people can say people who are satisfied or they're not satisfied. So the sample is a random sample. And p hat is the proportion of people who are satisfied, of the people who are satisfied with the way things are, right? With the way things are. With the way things are going. Okay, sounds good to me. Next one here. All right, describe this answering condition. Okay, I gotta remember that n was equal to 100. That was backwards, actually. Describe this answering distribution p hat, the proportion of Americans who are satisfied with the way things are going. Be sure to verify your model. All right, so, well, we can assume that the American population is really big. So 100 Americans, so n equals to 100. So if I do n times p times 1 minus p, I can assume that 100 sample from the United States is less than 5%. So a sample of 100 is less than 5%. I'll write that down here. So 100 times 0.82 times 0.18. Go find out what that is. So 100 times 0.82 times 0.18. That's 14.7, which is less than 10, which is greater than 10. Duh. So it's greater than 10, which is greater than or equal to 10. And we can assume that 100 is less than 5%, is less than 5% of the population. Okay, now I want to find the parameters. It'd be okay. Find the satisfying. So we want to find those two parameters. Well, so mu of p hat is equal to p, which is 0.82, and then sigma of p hat is equal to the square root of p times 1 minus p all over n, which in this case that's going to be the square root of 0.82 times 0.18 all divided by 100. So let's go get that over here. So clear. Okay, so what was it? Second square root of 0.82 times 0.18 divided by 100. I'm going to get that. And so that's telling me that this is 0.0384 and some change. I'm going to store that as alpha A right away so I don't forget. So stored alpha A so I remember. All right, so there's the checking to verify that the model requirements are verified. This is greater than 10 and this is less than 5%, and so here's our sample proportion sample variables, right? So our sample stuff here. Okay, so in the sample obtained in part A, okay, and remember n was equal to 100. What is the probability of the portion who are satisfied with the way things are is greater than 85? All right, so I have a sample of 100, so that's going to be kind of pointy. All right, and then the mean of this mess is 0.82, and I want to find 0.85. So I want to find the what is the probability the portion of the way things are in life exceeds 85. So this is this group here. All right, so I want to find the probability that x is greater than 0.85. If n equals 100, all right. So I want to find z of 0.85, and and that's going to be 0.85 minus 0.82 all over A, because I found that in the previous problem here. So I'm going to go 0.85 minus 0.82, get that, and divide by alpha A. So I got that number, and that's 0.7808. So I'm going to look at the probability that Z is greater than 0.78. So I can do that by going to a table. 0.78, where's that at down here? Okay, 0.78, and then this is 9, so 8, so 7823. So this is equal to 0.7823. And so this area, oh wait. So this is going to be 1 minus 0.7823, and that's going to be equal to 0.2177. So this area over here is 0.2177. All right, so that takes care of that. So the probability, right, so the probability that let's see, 85 out of 100. The probability that more than 85 out of that more than 85 out of 100 is satisfied. Is about 22%. Okay. Next problem here. All right. So would it be unusual for a survey of 800? Okay. So we have the same thing. Remember that n is equal to 100. All right. So we got this going on. This is a beautiful curve, and then this is 0.82, and then now we want p hat, so p hat is equal to x divided by n. In this case, it's 75 over 100, so that makes it 0.75. So this is 0.75 down here that I'm looking at. So this is 0. So I want to look at z of 0.75, so that's going to be equal to 0.75 minus 0.82 all divided by alpha A, because I had A already stored. So I'm going to go get that one. So 0.75 minus 0.82, get that number, and then divide by alpha A. Okay, that gives me negative 1.822. Now, since z of 0.75 equal to negative 1.822 is greater than negative 2, it would not be unusual to see 75 or fewer satisfied. Okay, so I'm using that 2 standard deviations below the mean, so this is negative 1.822, and I'm saving myself a little bit of work. All right, so next guy here. All right, so afraid of flying. Okay, so according to a study of the Gallup poll, the Organization of American Airlines who are afraid of flying is 0.10. So P is equal to 0.10. And a random sample of 1,000 resulted in 120. So N is equal to 1,100. And so P hat will equal to 121 divided by 1,100. Also, we could say X is equal to 121. All right. explain why this is not necessarily evidence that the proportion of Americans who are afraid of flying has increased since the time the Gallup study. Okay, so I guess what I'm going to do here is find some probabilities here. So, okay, so what do we got here? So, okay, so we got, now this is a different problem. So we got mu of p hat is equal to 0.10, and sigma of p hat is going to be the square root of 0.10 times 0.90 divided by 1100. That's going to be a small number. All right, so let's take this guy up here and go second square root of 0.1 times 0.9 divided by 1100. Oops, 1100. All right, so get that number. So that's going to be equal to 0.0090. That's good enough. All right, so now that's our distribution. So what we're looking at is would it be unusual? So let's go find this. So 121 divided by 1100. Oops, that's why I keep putting 1,000, because I wrote it down wrong over there. 1100. So this is 1100 here. Is 0.11. So now I have this beautiful distribution. I got, so this guy here, and I got 0.1, and I'm looking for 0.11. Now, well, let's go find that if this, is it unusual? So what's this area here? So, okay, so z of 0.11 is equal to 0.11 minus 0.1, all divided by 0.009. And I'm just going to type that in there. So 0.11 minus 0.1 divided by 0.009. So that's equal to 1.11. And so making sure I got that right. Okay, that's it, man. So that means this is 0, and this is 1.11. Now, that means that, so we can say, so since z of 0.11 equal to 1.11 is less than 2, then it would not be unusual to have 11% afraid to fly. Okay, I guess that would be the end. So so that's not evidence. Alrighty, I think, is there more? Nope, that's it.